Good morning, everybody. Thanks for joining us again this week. My name is Kevin Renaud with Peerless, and this week we have Oliver Valls discussing the double block and bleed, going over traditional methods, current best practices, and a little bit about different options available in double block and bleed. So as far as our introduction here, we again have a bunch of industries represented here: OEM, skid builders, chemical, engineering, industrial gas, power energy, some universities. And again, our geography covers 9 states, including San Diego, California. And if you're wondering, Oliver Valls is out in Cheshire, England, and that is about 5,323 miles to fly from San Diego to Manchester. And again, as far as Peerless goes, we've been around a little over 100 years, and we're proud of our, certainly proud of our past, but we're thrilled to be working with a customer base that's very diverse, skilled, and highly complex. Certainly Oliver Valls double block and bleed is an engineered product that we're happy to have been part of for about 12 years now. So our company operates in 3 different divisions. Our ProCore segment focuses on our OEM customers, custom engineered equipment, packagers, skid builders. Our process group we have that we call on the chemical, pharmaceutical, contractor, power, food, beverage, manufacturing, universities, and government. And again, our high temp fabrication division that focuses on high temp insulation product, refractory, scientific surfaces. So today we have Rob Porter. He is the area manager for England and Wales, again, out of Oliver Valls in Cheshire, England. Again, Dan Morgan will be acting as our moderator for today's event. Greg Barrell is our process group development manager. And again, I'm Kevin Renaud in business development. So again, typical, I introduce our presenter. Rob Porter's been in the business for over 20 years, spending most of his time in the North Sea environments. And I asked him a little bit about himself, and he said he liked football. So I'm like, oh, perfect. Not really. So this is his style of football. So he's a big fan. Liverpool was his first love, but now he's got some other interests out there. And then I asked what else, and he says, you know, the game where you swing a bat at a ball that's coming over the plate. And I'm like, oh, baseball. No. So again, cricket. So I don't know anything about cricket, but Rob seems to be an expert at it. So with this, I am going to turn it over to Dan Morgan, and he's going to cover how this will operate today. Dan?
Yes, thank you, Kevin, and thank you again to everyone for joining us. If you've been with us before, you can certainly tune me out for the next minute, but I just want to explain sort of how this is going to work. So as Rob is going through his presentation, I will be keeping an eye on things in the background. So you'll see in your control panel there is a questions panel, and we really want to encourage you to use that panel to ask any questions that you might have as Rob's going through his presentation. If anything comes up that you'd like some clarification on, or maybe like an application specific question that you know that you're thinking of, please by all means submit a question, and I will be keeping an eye on that. I'll either find a way to answer you right directly through that questions panel, or I will find a moment to interject within Rob's presentation so that we get that answer for you. So yeah, feel free. And with that, I'll turn it over to Rob.
Thank you, Kevin, Dan, for that brief introduction and the invitation. I hope everybody is well. Before starting, I just wanted to say thank you for Kevin and the team at Peerless pulling these presentations together. It's fantastic. Secondly, a quick thank you to those who have taken the time to attend at such an unprecedented and uncertain period of time. I know how incredibly hard it is for everybody at the moment, so we're thankful that you're here with us attending these calls. If I may, just a quick welcome to the Oliver Valves presentation for double block and bleed valves. Just a very quick overview of the company, elaborating what Kevin has already said. Olivers are based in Knutsford, which is actually near Manchester, correctly in Cheshire, which is in the heart of England. We've been producing high quality, innovative instrumentation products since 1979. Our philosophy and approach has always allowed us to expand our business to other markets such as subsea with Oliver Valve Tech and pipeline products with Oliver Twin Safe Valves. allowing us to become a market leader and trusted partner for many key end users. On to the presentation, which is primarily focused on double block and bleeds applicable to the instrumentation process. The valves in which we manufacture for instrumentation are typically flange by screw or flange by flange, as illustrated here. The function of the double block and bleed valves. The primary function of the system is for an isolation and a secondary intervention. The double block and bleed systems are needed when essential equipment needs removing, servicing for calibration, or cleaning and repairs. A primary isolation valve is typically covered by piping engineers for the driven specifications, and then the secondary isolation valve and tertiary vent valve are covered by the instrumentation engineer specifications. The double block and bleed system includes isolation or double isolation for safety, a vent port to release the trapped media in the cavity. And to continue that on, from the 1980s, Oliver's have always been the pioneers of the double block and bleed concept, combining the primary process isolation valve, secondary instrument isolation valve, and its tertiary vent valve in one single manifold, giving the true double isolation and vent capabilities, with improved safety and reduced leak paths, with weight reduction, reduced bending moments of stresses that can cause critical failure, and especially in horizontal takeoffs. These are generally produced, are recommended in line with health and safety legislation, such as OCEA 3132 and HSG 253, stemming from disasters such as the Piper Alpha in the North Sea, which some of you may remember, which was recently actually the anniversary this week, and then more recently on the P36 platform in Brazil. If we may now, we'll just introduce a very short video illustrating the use of a flange by screw DBB. Do you have any questions at this stage, gentlemen? Dan, is there anything else that you feel you need to add at this stage?
There's no questions so far, so I think yeah, I think we're clear to proceed.
Good, excellent, thank you.
All right.
Okay, on to the benefits of the double block and bleed valves. On the left of the slide here, we have the image illustrates a traditional hookup of 3 single isolate ball valves, a T-piece pipework, an instrument manifold to isolate the gauge, the trunking and support structure required for these. And on the right of that image is the small flange by screw double block and bleed valve, achieving the same solution. So on the traditional hookup of the 3 single isolates, you can expect to achieve a 40-inch length, and this is based on a 1.5-inch 1500 class single isolate ball valves. So those two coupled together in a line would achieve a 40-inch face-to-face dimension. Whereas compared to the Oliver valve solution, you're looking at a dimension of around 7 inches. Comparing the weight, on the left of the traditional hookup, it's approximately 100 kilograms, and on the right of the Oliver solution, about 7 kilograms. So you can see the benefits immediately of the weight reduction. On the left, as we've mentioned, it's the 3 balls, the needle valve, which include 24 bolts and 6 gaskets. And on the right, it's 1 single valve, 4 bolts and 1 gasket. So overall, you can see the benefits straight away. The space saving, reducing the total weight of the skid. Less weight, approximately around 75% can be saved on a platform, which can be critical, especially if the weight and space is the critical requirement for these skids being built. And then the reduced leak paths. So with the single isolates, you would expect there would be around 6 leak paths, with 1 on the new format. The cost saving, you would make many cost savings in the procurement teams where you're not sourcing multiple items, but only sourcing 1 item, and you're not considering the time for the construction, which would be required as well. So multiple items and the time it would take to install many compared to 1. We also offer a larger process return on full bore valves. We do the flange by screw and flange by flange valves. On the flange by flange valve, we can offer a very smooth, reduced or full bore. When compared to similar technologies that we compete against, which could be a butterfly valve, this could produce cavitation and high pressure drop. This would all equate to the full bore solution, giving you a greater output as an end user, so therefore would make you more bang for the buck. The Oliver Valves double block and bleed solutions. On the left, we have a traditional hookup with the demarcation line illustrating the single isolate closest to the pipework is managed by the piping engineers, and above the demarcation line, the vent valve and the second single isolate are managed by the instrumentation team. So we have to consider 2 forms of engineers that we may have to communicate with. Available within our range, as mentioned previously, is the flange by flange option, the flange by screw, the slimline monoflange, including the outside screw and yoke head units, and the monoflange with traditional head units. 2 ball and 1 needle valve. The images illustrate here the flange by screw and the flange by flange DBB valve. Traditionally, we manufacture them with ball valve isolates and a needle valve vent. 2 balls for isolation, 1 for primary, 1 for second, and the needle valve to bleed the cavity between the isolates. We have these available in bore sizes from 10, 14, 20, but all have a common vent, which is typically 5.4mm bore. They flange from ASME 150 through to 2500. We can also manufacture them with API flanges 3000 to 10,000 psi. We offer various hub connections available up to 10,000 psi. What you may wish to look for when selecting is, does the valve require to be fire safe? Does it need to be traceable with the CNTR in accordance with EN 10204 3.1? The needle valve, which is the bleed valve controlling the bleed, typically includes our standard non-rotating tip. And these are the benefits of the non-rotating tip, is you will have instant closure whilst the tip is not rotating, therefore creating a wear path and eventually a leak path. Typically, our valves are manufactured as a single one-piece forging, and the benefits of the forging can be seen in this illustration here. So on the left, we have parts produced by the forging process, and on the right, the same product produced by machining straight bar. So the grain structure is what we're trying to illustrate here. The grain flow from forging allows best properties in the direction required. Compared to a cast, the forging has far superior strength and toughness. Working during the forging process breaks up the grain structure, eventually resulting in a finer overall grain size, which gives much improved properties. The effect of generally surface breaking, whereas porosity in the casting remains hidden, so you never, in some cases, you may never find those defects. Fatigue resistance on the produced components is much improved by the presence of the grain flow, making the forging components ultimately a better, more reliable solution. The properties are consistent between items, giving a guarantee of properties throughout production. Improved properties allow higher stresses high pressures, which offer better improvements in our design and solution to the customer. Also within our range, with the double block and bleed valves, we can produce these with needle valves. Excuse me. The monoflanges can typically be produced with needle valve construction, so that would be all needle valve operation. As illustrated, we can do single isolate, block and bleed, or double block and bleed. The gauge block would typically work in conjunction with the primary isolate, where your piping engineer would push for a single isolate ball valve. You would then mount the monoflange on top of it, use the second isolation and vent. Valve designs are in accordance with the ASME P16 flange diameters and bolting, and as mentioned, we produce them as block, block and bleed, and double block and bleed configuration. Also available within the monoflange range is the outside screw and yoke. We call these the slimline. The slimline is classed as being suitable for piping engineers as a primary isolate valve. So therefore, you should be able to talk with the primary isolate within this range with both types of engineers. The block and bleed configurations come with dual instrument ports, and this allows for either vertical or horizontal mounting depending on your end user's solution requirements. Ultimately, again, we're offering the weight saving, the space saving, the hookup and leak path savings, which would give us the ultimate solution for the customer. Any questions that may arise so far, if anybody would like to interject? Dan?
Nothing's come through yet, but yeah, I'll again encourage everyone to keep that in mind. If something does come up, do not hesitate to ask, and we'll get it answered for you. So yeah, good for now, Rob.
Perfect. Okay, we'll carry on. Okay, onwards to the applications and valve selections. And illustrated here is the flange by screw and flange by flange double block and bleed valves. Typically, you'd use these in where you have high viscosity or particulates within the line. They're typically used in higher viscosity applications, so as you have either full or reduced bore. Like the ball valves are all produced with quarter turn for fast action isolation during emergency solutions, and they all have rollable bores and smooth bores, allowing the maintenance should they need to be cleaned. Offering an excellent DP with great pressure drop, again giving that best solution for the customer. On the needle valve, monoflange and slimlines, they're typically used where there's lower viscosity applications, certainly with no solids. The solids would simply block up the pores in there, which are very limited, 5.4 millimeters. So, we would certainly recommend clean services. The footprint, it's a very compact design, so ideal therefore for tight spaces when you're in a skid manufacturer with very limited spaces and weight reductions. The cost is most competitive style DBBs reduced with a flange connection, and we can offer these as mentioned with an outside screw and yoke head unit, as per the slimline illustration there, which is specified by those piping engineers. The needle valves themselves, by nature, by design, we can produce them with either PTFE or graphite seals, which allow us to operate in temperatures up to 540 degrees C. Whereas the flange by screw ball valve operated valves are typically up to 120, possibly 200 degrees C. Both solutions again offer that weight, the space saving, the weight saving, and a limited leak path. We're able to manufacture double block and bleeds in several different solutions, and again, for instrument hookups, we produce the Boston double block and bleed. These can be seen illustrated here with all ball valve operation with threaded connections. Again, all ball valve operations is a T-type. A needle valve vent facility with 2 balls isolating the line we class as an ID type, but again with threaded connections. And then finally, the solid needle valve operation, which is the IN type. Pressure and temperature ranges. In line with the ASME ratings for the 10mm bore valves, with our standard offering of PTFE, PCTFE, the maximum temperature for a 2500 valve would be 120 degrees C. On 10mm bores and the API ratings with a maximum pressure of 10,000 psi, the temperature would be 30 degrees C. The maximum survival temperature would be 200 degrees C. In line with ASME ratings, we can offer 14mm and 20mm bores with PTFE seats with a maximum pressure of 600. This would equate to 70 degrees C temperature, with a maximum survival temperature of 200 degrees C. ASME ratings for 14 and 20mm bores supplied with peak seats allow us to achieve 120 degrees C at 2,500 pressure. Again, with a maximum survival temperature increasing to 250 degrees C with peak. API ratings for the 14mm bore and peak seats are rated to 10,000 psi, 120 degrees C. As can be illustrated here in the pressure temperature curve, we can produce as and when needed. The fire safe requirements of the valves. All of the valves offer fire testing which can be done in-house in our own facility. We have several standards that we need to adhere to. BS 6755 Part 2 is now obsolete and was superseded by ISO 10497, API 607 and API 6FA, which are all very similar. When we carry out any new form of testing, we dual certify to all ratings. All DBB valves carry a fire-safe design of the seats and the seals, given that some of the valve is suitable for the application. In regards to fugitive emissions testings, again, we offer an in-house solution, and we do this for either approval of new designs or production valves. Emission vapors or gases from equipment due to leaks or other unintended irregular releases of gases. They offer serious potential hazards to health and contribution to the pollution in the environment. And they're designed in accordance with the ISO 15848 Part 1 and 2. Testing is typically carried out using helium on all sizes and all types of valves are covered. And all of the pressure ranges that we offer in accordance with 150 to 2,500, from -46 to 200 degrees C. The fugitive emission sealing is managed or maintained as offered in accordance with the mass spectrometer. We measure very small leak rates, typically less than 50 parts per million on the body seal. And the stem seals, we offer 3 tightness classes, A, B, and C, all utilizing helium as illustrated. Measured using helium leak detection or a mass spectrometer as illustrated on the right. And the leakage rate A has to be measured in a vacuum scenario, being so critical. Onto additional valves, we can offer the double block and bleed valves with sampling and injection valves as illustrated here. Sample probe with 45-degree cut, injection probe with a plug end, a 3mm hole in the side wall, or a square cut probe end at 45 degrees. We can offer specific spray nozzles to ensure that the flow or spray patterns can be achieved again when injecting in the line to ensure that the medium maintains the suitable viscosity. What we have to be careful of is the weight frequency calculations when offering probes and mills. Media striking the probe and low pressure vortices create potential for mechanical failures due to fatigue. Probes must be suitably robust, and the standard we use is the ASME PTC 19.3 TW 2016 for thermo wells. And this offers the vortex shedding theory as the basis, also known as flow vortices or von Karman vortex street. Shedding can occur at frequencies from 50 Hz to 1500 Hz. Ladies and gents, that concludes the short presentation on the double block and bleed valves. I hope that it was of some use and would open the floor now to any questions that anybody may have.
Yep, thanks, Rob. At the very moment, there are no questions that have been submitted, but as I turn this presentation back over to Kevin real quick, we are going to be hanging out for another couple of minutes. So please do, if there's anything, application specific, anything technical, anything that you maybe want to see Rob go back over again, please do send in a question. Oh, we got a couple of coming in now, so let's fire them off here. First one that just came through, Rob. Do you have the ability to offer or produce CAD models for your valve designs?
Oh, sorry, I missed that. It wasn't particularly clear. Do we have the possibility to offer
CAD 3D models?
Yes, we do. Yes, yeah, we can do 2D or 3D CAD models.
All right, perfect. In terms of materials of construction, is there a setup or option that is possible with a PTFE lined version of these valves? Is that anything you've come across?
No, we've never offered a lined valve for double block and bleed valves as we stand. So what we would typically suggest is that we would come up with a suitable material. So generally the bodies and balls are always of a metallic nature, and we would ensure that with your process engineers that we would come up with the right material for the media conditions.
Perfect. Okay, those were the only couple we had right now. So again, if there's anything else, follow-up question to that. Is there, I guess not sure if this is something that we maybe want to follow up with after the webinar, but yeah, I think you maybe just covered it, but certainly the question is basically like, is there basically a different alloy substitution that you would use, in lieu of the PTFE lined or wetted? So I think you pretty much just covered that.
Yeah, it would be very dependent on what the media is. So first and foremost, we need to understand the media and the temperature, and this would guide us to what would be the best materials, whether that be the more common materials of carbon steel and stainless steel. All the way through, we've produced these in Manel, Inconel, duplex, super duplex, and even titanium. So I would suggest that there'd probably be a suitable material. And as Andy mentioned there in the background, we also produce these with metal seats. So is there any of those medias that you're working with have solids or are very aggressive medias, then we can offer metal seats in lieu of soft.
Very good. I'll see if there's any additional follow-up to that, or possibly follow up after the webinar with some more details on that. But that is all we have so far. So I don't know, Kevin, maybe if you want to mention a few things here.
Yep, thanks, Dan. Thanks, Rob. We really appreciate your help here today. Once again, we do thank you. And Oliver, we've been working with them for quite a few years, and we have provided valves in Super Duplex and Manel and Hastelloy C for sure. So I do want to mention again that they do have valves from 1/2-inch needle valves all the way up to 16-inch process DBBs. And there is a really cool video here that's 2 minutes that demonstrates how this, what they call a CSL, it's a cartridge standard length, how this is built to fit within the normal footprint, the normal end-to-end dimension. So you can take out a single isolate and throw this double isolate in. And I'm going to show that in just about 30 seconds. But I do want to let you know that we are working on our preparations for next week's, and we'll announce that in a follow-up email. And in the meantime, all our past recordings can be found at our website in our training section. And of course, we have a catalog of what we call any day one-on-one tailored training, and that's on the same training page. So that can be found on our website. At those links, you will see this in a recording. We'll follow up with that. And as promised, I do want to show you this video, and we're just going to leave you with that.
Yeah, this is a great video. The one thing that I'll just add sort of as this plays is once the webinar ends here after this video plays, there will be a brief little survey that'll pop up for you guys. And we'd hope that you'd be able to provide some feedback and let us know how we did today and what we could maybe do differently next time. So it's just a couple question quiz. So we'd encourage you to take that and provide any feedback that you could. So thanks.
All right, thanks for sticking with us once again. Thank you. We are going to gauge interest on a follow-up presentation on this specific model, which is the twin safe. So again, thank you. Have a great week, and we'll talk to you soon. Bye now.
Everybody, thanks.